In this video, we're going to look at infinite limits, and that's where the limit is itself, either infinity or negative infinity. In the previous video, we looked at limits as x tended to either positive or negative infinity, but here, the limit itself, like what f of x approaches, is either positive or negative infinity. So the first example we're going to look at is the limit as x tends to positive infinity of x squared. And here just the value that x tends to just happens to be infinity, but that's not what I'm referring to when I mean infinite limits, and hopefully you'll see what I mean by that. So x squared, it goes through 1, 1, 2, 4, and just increases like that. And kind of the same deal on the negative side. We're interested in what happens as x approaches positive infinity. What happens to x squared as x approaches positive infinity? So as x gets bigger and bigger, well, x squared is naturally going to get bigger and bigger. So, if x is 10,000, well, x squared is going to be 10,000 squared. If x is 10 million, x squared is going to be 10 million squared. So this limit, we can say that the limit is positive infinity. Now, of course, here comes a problem that infinity is not really a number. So, but some math teachers still say it's okay for you to say that the limit as x tends to infinity of x squared is infinity. Some would prefer that you say the limit does not exist. So some teachers prefer you to write the limit does not exist. Remember, we abbreviate does not exist with DNE. And be sure this is not 2, it's not TOO, this is positive infinity. Okay, so some teachers prefer that you write the limit does not exist, but some prefer that you say the limit is positive infinity. So what does that mean, positive infinity? It means that if you pick any number, like let's say you picked 10 million, you can find a value of x where f of x would actually be more than 10 million. So say you let x itself be like 9 million. Well, 9 million squared is more than 10 million. So no matter what value you pick for no matter any number you pick, you're always going to find an x value for which f of x exceeds that number. And that's essentially what this positive infinity is telling you. So you pick a value for x, you find f of x at that value. There's always going to be an x value that you pick for which f of x is going to be even bigger than that value. So as x gets bigger and bigger, we say that f of x approaches positive infinity. Some teachers would prefer you say that the limit doesn't exist, but this actually does have a definite interpretation, and that's that no matter what number you pick, you can find an x that would generate f of x that exceeds that number. Okay, we'll take a look at a couple more quick examples here. Well, really one more example. It's going to involve two constituent examples. So it's the limit as x tends to infinity of 1 over x. So 1 over x, looks kind of like this. This is 1, 1. This point here is 1, 1. This point here is 1, negative 1. And we're actually interested in the limit as x tends to 0 of 1 over x. As x gets smaller and smaller, from the positive side, closer and closer to 0, so we're talking smaller and smaller positive fractions, the reciprocal of those positive fractions are going to be larger and larger number as those larger and larger numbers as those fractions become smaller and smaller. And approaching 0 from the negative side, as the fractions become smaller and smaller negative numbers, the reciprocals will become larger and larger negative numbers. So the limit as x tends to 0 from the right, if you remember from the earlier videos, the notation for x tends to 0 from the right is x arrow 0 and with a plus superscript denoting from the right. So limit as x tends to 0 from the right, 1 over x is positive infinity. So as x gets to be smaller and smaller fractions, closer and closer to 0, 1 over x becomes larger and larger positive numbers. And we say positive infinity. Some teachers would prefer you say limit as x tends to 0 from the right of 1 over x doesn't exist, but there is a definite interpretation, and that interpretation is you can always, if you're given a number, you can always find an x for which f of x will exceed that number. If you're given 10,000, you can pick an f of x, or you can pick an x. In this case, you'd pick, say, 1 over 11,000. And 1 over x, which is 1 over 11,000, would be 11,000. That would exceed the 10,000 that you picked. Now for approaching 0 from the left, and this negative sign next to 0 just means from the left. It doesn't mean that x is negative. It means you're approaching 0 from the left. So for example, if we wanted to approach 1 from the left, we'd still put this negative superscript on top of the 1. But anyway, approach 0 from the left, limit as x tends to 0 from the left of 1 over x is negative infinity. So if we're looking at smaller and smaller fractions, that is fractions closer and closer to 0, the closer x gets to 0, the reciprocal of x is going to be larger and larger negative numbers. So we say the limit as x tends to 0 from the left of 1 over x is negative infinity. The interpretation is that no matter what number you are given, you can find a value for x such that 1 over x is a larger negative number than that assigned number. So let's say you're given negative 10,000. Let's say you let x equal 1 over negative 1. Or let's say you're given the number negative 1 over 10,000. If you let x equal negative 1 over 11,000, then 1 over x would be negative 11,000, which is a more negative number, a larger negative number than negative 10,000. And that's the interpretation of this limit as x tends to 0 from the left of 1 over x being negative infinity. So that this is x tends to 0 from the left, not of 1 over x, not a limit as x tends to 0 of negative 1 over x. That may have confused you there. And now these right and left limits are not equal. So if you wanted to find the limit as x tends to 0 of 1 over x, and this takes into account both the left and right limits, If they're the same, then the limit is a definite. We could say, if let's say the limit were as x tends to 0 from the left, instead of being negative infinity, if it were positive infinity, then we could say this limit is positive infinity. But since that's not the case, we say this limit does not exist. And there should be no ambiguity on that, because coming in from the left, you approach large negative numbers, but coming in from the right, you approach large positive numbers. Larger and larger positive numbers. So for the left and right-handed limits, they individually, those limits, there may be some debate as to whether, say, the limit as x tends to 0 from the right is either of 1 over x is either positive infinity or does not exist, and whether the limit as x tends to 0 from the left of 1 over x is either negative infinity, or perhaps we'll say it doesn't exist. But when looking at just the limit as x tends to 0, taking into account approaches from both the left and the right, we say it doesn't exist because coming in from the right, you tend towards larger and larger positive numbers, and coming in from the left, you tend towards larger and larger negative numbers. So there is no ambiguity. We say the limit as x tends to 0 of 1 over x does not exist. In these cases, we weren't approaching, x did not approach infinity or negative infinity, but the limit itself was either positive or negative infinity. And remember, the limit is the value that the function f of x, the dependent variable, tends toward. And that'll do it for this video.